Hello everybody and welcome back to Advanced Maths. Today we're looking at differentiation, increasing and decreasing functions. Here's a function, y equals f of x. If you look at this function, it's got a tangent here and the tangent is going upwards. And for this region of the function, it is increasing, the function is getting bigger because the tangent is pointing upwards. And so we say the gradient is positive and the function is increasing. For all of that green region there, the function is going up. But here, the gradient is flat. The tangent is flat. The function is not increasing or decreasing here. And we call this point a turning point as it's turning from going increasing to decreasing. At that point there, the gradient is 0 because the tangent is flat. Here, the function is now decreasing, it is going down, and so the gradient is negative. We've got another turning point here, and this is called a minimum. Our other point before was called a maximum. Because it hit a maximum, this is hitting a minimum. These are both turning points because it's turning from increasing to decreasing or decreasing to increasing. And finally, we've got this part over here where the tangent gets steeper and steeper and it is an increasing function. So we've got increasing, decreasing and increasing again, and we've got two turning points between them. Okay, so let's see an exam question on this. Consider f of x equals 3 minus x cubed minus 3x squared. Find the values of the coordinates of the turning points of the function. Find the values of x where the function is increasing or decreasing, and hence we're going to sketch the curve. Okay, let's look at part A first, and we're going to find the turning points of this function. To do this, we're going to differentiate it first, because at the turning points, we know the gradient is 0. So we differentiate it to find the equation for the gradient, and we're then going to make this equal to 0. Because the gradient being 0 is a unique property of turning points. The tangent is 0, has a gradient of 0, therefore the gradient is 0. We make the derivative equal to 0, and now this is a quadratic equation that we need to solve. We factorize it, and now we can solve it by finding x equals 0, x equals minus 2. The minus 3x is equal to 0, or the x plus 2 is 0, therefore x is 0, or x is minus 2. We have solved the quadratic, and now we know the x coordinates, where the gradient is 0, the turning points. We can now find the y coordinates. And we're going to do that by substituting the x coordinates into the original function. Not the new derivative, the original function tells us the y coordinates. We're going to put x equals 0 in, and when we evaluate that, we get 3. So the coordinate is 0, 3. Now we're going to put minus 2 into the function. F of minus 2 looks like this, and this evaluates to minus 1. So the turning point is minus 2, minus 1. And now we've got the two turning points of the cubic equation. Okay, now, find the values of x where the function is increasing or decreasing. Well, we know that it changes at the x coordinates minus 2 and the x coordinate of 0. They are the turning points where it stops increasing or it stops decreasing, and it starts increasing or starts decreasing. And so to find out when it's increasing or decreasing, we focus on the point on the regions of x between these two turning points. So let's start with x is less than minus 2. That is less than the first turning point. And what we'll do is we'll substitute a number less than minus 2. We'll substitute in minus 3 and see what happens. F dash of minus 3, if we evaluate that, is minus 9. So the gradient less than minus 2 is negative. And so we can say that the derivative is negative, and so it's going downwards before minus 2. So we're substituting x value less than 2 into the derivative, less than minus 2 into the derivative. The gradient was minus 9, which is negative. So I can conclude that it's decreasing here. Now interesting between minus 2 and 0. So we substitute the number between minus 2 and 0. Minus 1 works perfectly. Put that into the function. And we see that here it is a positive gradient. It is increasing here. Now for x is more than 0, we substitute in x, a positive x. So let's substitute in 1, that is more than 0. And we see that the gradient is minus 9. So we know the for the first section, x is less than minus 2 is negative. Between minus 2 and 0, the gradient is positive, and x is more than 0, the gradient is negative again. So when the derivative is negative, it's going down, it's decreasing. When it's got a positive gradient, it's increasing, and when it's negative, it's decreasing. And this is how we figure it out. In an exam, I would recommend drawing a table like this so you can really figure out where the function is increasing or decreasing, and that really helps you to figure out things in exam questions, and it's a really clear way of presenting your work. Okay, so now we're going to sketch the curve. Well, we know it's got a minimum and maximum at these points here. It's got turning points of minus 2, minus 1, and 0, 3. We're going to roughly sketch on where we think minus 2, minus 1 is, and where 0, 3 is. And we're going to label those coordinates as well. Now it's decreasing at the start, and it's increasing in the middle, and then it's decreasing at the end from our table. So we have a rough idea of what the curve looks like, and it will be a smooth curve that roughly follows that pattern. It will look like that. And so now we have drawn a perfect sketch, well, a good enough sketch to get the marks in the exam. I labelled the turning points, and I also showed where it's increasing and decreasing. And that's it. That is an exam question on increasing and decreasing functions. You've now got some practice questions to try yourself. So you've got f of x, g of x, and h of x for you to try and solve yourself. Find the coordinates of the turning points, find the values of x where the functions are increasing or decreasing, and hence sketch the curves. So I'd like to pause the video now and try this yourself. It should take you about 10 minutes. When you're ready, I'll allow you to press play, and I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thank you for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. You can also check out advancedmaths.com for more revision resources. Thanks for watching, and good luck in your exams.